What's up, everybody? Mr. Kozad back again with another video lesson. Thank you for finding me. Thanks for finding this video. Thanks for finding this channel. Whether you're here because you have to be, because you're one of my students, or whether you're here because you just found us somehow on the YouTube, welcome. I'm so happy that you're here. Before we do anything else, I've got to tell you today is a great day to be alive. I don't care where you are, how you are, it doesn't matter. Today's a great day to be alive, and I'm so happy that we get to spend the next little bit of time together. I hope that you find this video to be helpful for you. The topic of today's lesson is on conic sections, and we're specifically looking today at a parabola. Okay, so we're going to be looking at the conic sections, and today specifically talking about parabolas. We're going to look at them in kind of some different ways than you may have looked at them in the past. If you're my student and you're using our textbook, this is section 9.2. So, get something to write with, get something to write on, and let's dive right in. Here we go. So the very first thing that we're going to do is we are going to label some of the important parts of a parabola, okay? Now, it would be so boring, blasé, if you will, to center a parabola at the origin, okay? So many times we center put the vertex of a parabola at the origin, but that's just not what we're going to do here. We're going to have a little more character in our life, add a little bit of color, and do things a little bit more interesting. So we're going to slide our vertex around. So the first thing that you should, if you've made it this far in Algebra 2, you should be able to find where on a graph the vertex of a parabola is located, okay? We know that this point here is the vertex, okay? And the coordinates of that point will be at HK. I'm going to have to probably make my pen a little bit smaller to get this all to fit, okay? So start with that, label that. Now, the next attribute that I want you to see is this dashed line that passes through the vertex is the axis of symmetry. It's the axis of symmetry. And again, that should be a familiar concept for some of you. The axis of symmetry is a line that cuts something in two equal halves, okay? So that's pretty self-explanatory. The next attribute that you have is this little point right here, okay? There is a point that exists on the axis of symmetry, okay, on the interior of the parabola that is called the focus. It's called the focus. It's a focus point. Every single parabola has a focus point. It will always be on the interior of the parabola. The way that I like to think about it is imagine the parabola like a mouth, and the mouth is always eating the focus. So the focus will always be on the interior, on the inside of that parabola, okay? Let's get a couple other attributes, okay? Oh, man, one of my most favorite. This line segment out here, okay? This line segment out here that's perpendicular to the axis of symmetry has a really, really cool name. It's called the directrix. The directrix is a line segment, okay, that has a really close relationship with the focus, okay? Now, pay attention to this next part. It's probably the most important part of this entire lesson, okay? The focus and the directrix are the same distance away from the vertex. Another way of saying that is that the vertex is the midpoint or in the middle of the focus and the directrix. Those line segments are the same length. And more specifically, those line segments are P units. Now, that doesn't make any sense to you right now. You're like, P units? What the heck does that mean? PU, that stinks. No, okay, bad joke. P units, okay? P units is the distance from the vertex to the focus and also the vertex to the directrix. We'll address that in the next slide, but for right now, I do want you to label that on your picture here, okay? Let's see if we have, this is my least favorite one, okay? This last attribute here is there's a line segment that passes through the focus and ends on each side of the parabola that has a name. Its name is the lattice rectum. It's okay if you laughed out loud. Okay, lattice rectum. If we were in class, everybody would laugh. One person would probably make some sort of rectum joke. So hopefully just get it out of your system now. It's called the lattice rectum. okay? Now, one other thing that I'd like you to write before you move on next to this graph, it's really, really important. Write yourself a note that the focus and directrix are p units from the vertex. That is a really, really important fact that's going to be really important for you to remember in this lesson, okay? So now the next slide, what we're going to do is we're going to look at, there's actually two different types, there's actually four different types that we categorize into two buckets, four different types of parabolas that we're going to look at, okay? We are going to look at parabolas that open up and down. Those are the ones we're the most familiar with. But we're also going to look at curves that are parabolic in nature, that are the shapes of a parabola that actually open to the right and to the left. Okay, we're going to look at some parabolas, again, that open up and down. We're very comfortable with those. But we're also going to start looking at some parabolas that open to the right or to the left. Now, like I said, four different categories, but the up-downs stay together and the left-rights stay together. Okay, so if you are taking notes on your own, I would definitely pause the video now and I would recreate this table in your notes. This is actually going to be really, really useful for you. So pause it now, recreate this table, and then jump back in when you're ready. Okay? Welcome back. Hopefully you've got a beautiful table set up, or if you already printed the notes beforehand, man, that's awesome. Okay, so we're going to go through some of this. Now, I'm going to go through this, and this might be a part of the video that you need to go back and listen to a second time, okay? I'll try to slow down, but I go a little faster here than in class. So bear with me. You might need to listen to this a few times, okay? So the first thing that I want you to look at is there's two options for an equation, and they are both very, very similar. The only thing that's different, okay, the only thing that's different is which variable is being squared, okay, which variable is being squared. So if you look at this first column, okay, this one right here, this first column, the variable that's being squared in the first column is the y, okay, the y. So if y is being squared, this is going to be a set of parabolas that either opens left or they open right. If y is the variable being squared, your two options for the direction of opening are it either opens to the left or it opens to the right. Now, more specifically, we can be more specific. It's going to open to the left when the p-value is less than 0, which means the p-value is negative. If we flip that around and we have a positive p-value, that's a type of parabola that's going to open to the right. Now, if you look at the equation, okay, if you have a negative p-value, that's going to make this constant, this coefficient here, that's going to make that a negative number. So you're really looking for this expression here. Is it positive or is it negative? Okay. Okay, so next, the vertex. Now, the vertex here was always going to be located at HK. That's going to be true no matter what, and that's actually going to be true for all of chapter 9. The vertex is always located at HK. Just a real quick reminder for you, okay? Remember that H is always with X, K is always with Y. It doesn't matter which variable is being squared. The number with the X is always H. The number with the Y is always K. All right. Now, the axis of symmetry. So what we have to think about here is we have to think about these parabolas. So if parabolas open to the right or to the left, okay, the axis of symmetry, the line that cuts them into two equal pieces, is actually going to be a horizontal line. So the way we write the equation of horizontal lines is y equals. Now, if you go back and look at the picture that we just labeled, notice that the axis of symmetry always passes through the vertex. So, if you want to write the equation of a horizontal line, that's not what I wanted, a horizontal line that passes through the vertex, the equation of that line is pretty simple. It's going to be y equals k. It's going to be y equals k. Now, moving on, the focus point. Now, this is where you've really got to lock in on the focus and the directrix. It's probably the hardest part about drawing these graphs. Okay, remember, that the focus is p units to the left or right of the vertex. Remember that it's p units to the left or the right of the vertex. Okay? So here's how we can figure that out. Okay? Here's how we can figure that out. If we start at the vertex, and if I move to the right or to the left by p units, I'm changing the x value. So we're going to think about that as h plus p, comma k is the location of the focus. Now, what actually happens if you remember it like this is h plus p, okay? That's going to take into effect whether p is positive or negative. It's going to shift that coordinate the correct way if p is positive or negative, okay? So trust me, think h plus p. Add p to the x value of the vertex, keep the y value the same, and that's going to be the location of your focus. Now, your directrix is going to be, the note I want you to write for that, is your directrix is the opposite direction as the focus. So it's the opposite direction as the focus. And remember from your diagram that the directrix is the equation of a line. Now, the directrix is always perpendicular to the axis of symmetry. So if the axis of symmetry is horizontal, the directrix is going to be vertical. And we write the equation of vertical lines as x equals. Now, if we want to go the opposite direction that we went for the focus, instead of doing h plus p, you're going to do h minus p. So the directrix, remember, is a line that's on the exterior, the outside of the parabola. It's going to be h minus p. It's going to be h minus p, okay? And lastly, the length of the latus rectum, okay? Hopefully you got all your giggles out of the way when we labeled it on the graph. But the length of the latus rectum is going to be the absolute value of 4p, okay? It's going to be the absolute value of 4p. So you're going to find whatever that numerical value is, and you're going to take the absolute value of it, and that's the length of your latus rectum, okay? So this first column are the parabolas that open to the right or the left. Now let's talk about the ones that we're maybe a little bit more familiar with, the parabolas that we get when x is being squared, okay? When x is being squared. So if x is being squared, you either have an up or a down parabola, a parabola that opens up or a parabola that opens down. And you can tell by looking at this number here, whatever that number is, if p is positive, let's keep it the same color. Whoops, forgot that in there. If p is positive, that parabola is going to open up. And if p is negative, the parabola is going to open down. Okay? Next item is the vertex. Remember I said earlier that the vertex will always be located at hk. Now the axis of symmetry, if you look back at the parabola that we labeled, you can very clearly see that it's going to be a vertical line, okay? And we write the equation of vertical lines by writing x equals. So you're looking for the equation of a line that's vertical and that passes through the axis of symmetry. So that's going to give me x equals h. Remember here we can do that same note that we wrote down, that the focus is p units instead of to the left or the right, okay? For these types of parabolas, it's p units up or down from the vertex. You either go up or down from the vertex. So we can follow that same pattern here, but when I go up or down, I'm changing the y value. So my vertex, or my focus here, will be h, comma, k plus p. Now the directrix is still the opposite direction as the focus. And if you look at the picture that we just labeled, the directrix here is going to be a horizontal line. So the equation of that line is going to, instead of being k plus p, it's the opposite. It's k minus p. Remember, we go the opposite direction. And the length of the lattice rectum is still the absolute value of 4p. Now, make yourself a note down here at the lattice rectum that absolute value is always positive, okay? So you should never have a length that is negative. So just remember that. It's always positive, okay? Now, that's a lot of information, and there's probably about a handful of you. Well, there's probably only a couple of you watching this at one time. So let's maybe say, I don't know, 20 to 30% of you that are just completely lost. You're like, Jose, I have no idea what you're talking about. How in the world are you taking parabolas? I thought I knew parabolas, and you're making them so much more complicated with all these formulas and all this stuff to remember. I promise you that if you stick with me for the next couple of examples, this is all going to make a ton of sense when we are done. I promise you. Just stay with me, my people. Stay with me. I would not lead you astray. Stay with me. You're going to do great. All right? Let's put it all together in the context of some problems, and let's have some fun. Here we go. Example number 1. It says graph the function and label all of the attributes. And here's the function. X minus 3 squared equals 12 times y plus 4. Okay. Step number 1 is to identify which direction it opens. Okay. And to do that, look and see which variable is being squared. Okay. So very clearly, x is the variable that's being squared. So this is going to open either up or down. Okay. Now, we can be even more specific than that, and we can look at this number, this constant, this coefficient over here on the right. If it's positive and x is squared, it's going to open up. It's going to open up. So we know right now that this parabola is going to open up. That's a really, really important thing for us. Okay. Now, what I like to do is once I know that that parabola opens up, I'm going to come over here and I'm just going to draw a rough sketch of a parabola that opens up. Okay. So the next thing that I'm going to do is I'm going to find the coordinates of the vertex. Okay. So step number 2, find the vertex. Now, the vertex here, let me make this pen a little bit bigger. Okay. The coordinates of the vertex, there, that's better. The coordinates of the vertex, we use our h value and our k value. Our h value is always with x. Our k value is always with y. But Cozad, you just messed up. Shouldn't it be -3, +4? We go back and look at the formula again. It's x minus h and y minus h. So you have to flip the signs. Okay, so the vertex is actually at 3, -4. Okay, next step. Step number 3 is to find p. Find p. Now, this is actually a pretty straightforward and easy process. What we're going to do is we're going to remember that 4p equals that that coefficient on the other side. So 4p equals 12. Divide both sides by 4, and you get p equals 3. Now, you all are smart people. You probably know that this equation here, it's always going to be simple to write, okay? But it may not always be as simple to solve as p equals 3. But writing the actual equation here is always pretty easy. It's going to be 4p equals whatever that number is. Okay, so our p value equals 3. Okay, so then what we're going to do, okay, is we are going to remember from our diagram that the focus is going to be up here somewhere, and the directrix is going to be a line segment out here, where the vertex is equidistant. Now, since we know that p is 3, we know that the focus is going to be 3 units above the vertex, and the directrix is going to be 3 units below the vertex. So now what we can do is we can actually go through and start to label some of our important attributes. Okay, all right, so the vertex, we already found that. That was at 3, -4. Okay. The next piece of information we're going to find is the focus. Okay, so the focus goes up 3 units from the vertex. So keep the x value the same, and add 3 units to the y value. So that location is going to be at 3, -1. Pretty straightforward, pretty easy, okay? The next attribute is the directrix, okay? Remember, the directrix is the equation of a line, a horizontal line to be more specific. So it's going to be y equals, okay? And we go down 3 from the vertex. So if I go down 3 from -4, that puts me at y equals -7. And the last piece of information that will second to last is the axis of symmetry. The axis of symmetry is vertical, and it passes through the x value of the vertex. So that would be x equals 3. And the last thing that I'd ask you for is the length of the lattice rectum, and that is just 12 units. Remember, we take the absolute value of the value for p. So that would be our lattice rectum there. And that, ladies and gentlemen, is a graph of the function, and we have labeled all of the important attributes. Okay? Let's try another one. Okay, so it says graph the function and label all of the attributes. Again, this is, wait a second, my people. 2x minus y squared equals 4y plus 10. Can you hear that? It sounds like our good friend Hassas. Hassas, you say? Yes. If you are not one of my students or you do not remember completing the square from first semester, man, you are probably very, very confused by this. If you're not my student, stop now. Go find the video on completing the square, and you'll understand what I'm talking about when I say Hassas. Okay, it's an acronym that's going to help us do this. So before we can have some fun finding the attributes here, we have to do a little bit of work with Hassas. So very clearly you can see by looking, this is not formatted the way that we want it to. Okay, so what I'm going to do is I'm going to get the y values on one side and the x values and the constant on another. Okay, so algebraically speaking, let's see, we've got 2x minus 10 equals y squared plus 4y. That's just some basic algebra of moving some terms around. I don't need to go into a lot of detail on that. Okay, so now when we do the process of completing the square, okay, we leave the left-hand side alone, and we're going to create our perfect square trinomial. Now, what Hassas allows us to do is it's an acronym for half, square, add, subtract. So to half, you take the middle term and you have it. 4 divided by 2 is 2. Then you take that number and you square it. 2 squared is 4. Then you take that number and you add it and also subtract it. So what we just did is we created a perfect square trinomial right here. Okay? Now, if I add 4 to the other side, I end up getting 2x minus 6 equals y plus 2, the quantity squared. Now, this looks a lot closer to what I want it to be, with one small exception. If you don't pay close attention, you wouldn't see it. If you look over here at 2x minus 6, I need to factor out the 2. So when I do that, I get 2 times x minus 3 equals y plus 2, the quantity squared. Now this looks exactly like the form that we took notes on that I want it to be. Okay? So now let's go through some of our similar steps. So step 1 is to figure out which direction does it open. Okay? So start by identifying the variable that's being squared. So y is being squared here. So that means it either opens up or that means it opens down. Okay? So then I'm sorry, not up or down, it's right or left. I misspoke. Sorry about that. It opens right or left because y is being squared. So then we come over here and we look at the coefficient. If the coefficient is positive, that's a signal to me that it's going to open to the right. It's going to open to the right. So then what I'm going to do is I am going to draw myself a sketch of a parabola that opens to the right. I know the vertex is going to be located right in the middle. I know the focus is going to be a point on the inside. I know the directrix is going to be that same distance, but on the exterior. So now, the next thing that we can do is let's find the vertex. Okay. So the vertex, remember we take our h value and our k value. Remember that h is always with the x value, and k is always with the y value. So the vertex here would be at 3, -2. So now step 3 is to find p. Now remember what I told you. Take that number, whatever it is, and set it equal to 4p. And then very clearly you can divide, and you get p equals 1/2. Okay, p equals 1/2. So let's go through and let's identify some of our attributes. So we already got our vertex at 3, -2. For the focus, let's go ahead and add on here that I'm moving 1/2 unit. Okay, so those are all going to be really, really close to each other. Okay, so if I'm moving to the right 1/2 units, I add 1/2 to the x value of the vertex. So that's going to be 3.5 -2. The y value stays the same. And then if we found the equation of the directrix, that's going to be x equals 2.5 as I move 0.5 units to the other direction. The axis of symmetry, okay, is y equals 3. And then the lattice rectum has a length that's equal to the absolute value of 4p, which is just 2. The length of the lattice rectum is just 2. We could say 2 units if we want to be official. Okay? So hopefully example 1 and example 2 showed you that there is, that kind of brought some of those formulas that we talked about earlier to life a little bit. There's really not as much to remember maybe as you were worried about. Okay? We have 2 problems left. We're almost there. Okay? Example 3. Now example 3 is a little bit different. It says write the equation of a parabola with a focus at 3, 2 and a directrix at y equals 8. So half the battle in this section is you're going to be given the equation and asked to identify the attributes. But the other type of question that you're going to see is you're going to be given attributes and asked to write an equation. Okay? So first things first, let's draw a picture of what is given to us. Okay? So I'm going to just start with a point. Okay? I don't even need to draw a graph. I'm just going to say that that's the point 3, 2. Okay? So that's the focus. Now they tell me that the directrix is at y equals 8. So really, so far, the hardest thing I will have had to figure out here is to figure out is y equals 8 above or below that point. And hopefully you can make the connection that it is actually above. If you did not know or did not understand that y equals 8 is above the point 3, 2, I don't know that I can help you with that. Okay, so take a break, go get a snack, and come back later. Refresh your brain. Okay, so if this is the directrix, it's at y equals 8, and this is the focus, I know that the vertex is going to be somewhere in the middle, and I also know that this parabola is going to open down. Well, Cosette, how do you know it opens down and not up? Well, it's that when we labeled the graph, I told you that the parabola will always equal the focus. It will always eat the focus. So the focus needs to be on the inside of that parabola. Okay? Now, the other thing that we know about this is we know that this distance here and this distance here has to be the same. Okay? It has to be the same. So ask yourself the question, how far apart is the focus and the directrix? Well, if the focus is at 2 and the directrix is at 8, we have to go up 6 units. So if the total distance is 6, a lot of you are probably already ahead of me, you know that this distance here needs to be 3, and this distance here also needs to be 3. Well, what that tells me then is that tells me that the p-value equals 3. Okay? Now, let's be a little bit more specific. Actually, it's not exactly 3, okay? It's actually -3, okay? It's -3. Now, why is it negative 3? Okay, because remember, which direction is this parabola opening? It's opening down. So if it's opening down, you know that it has to have a negative p-value. So the absolute value of p is 3, but it's negative because the parabola opens down. Okay? Now, the next hardest step of this problem is to find the vertex. Now, remember that the vertex is halfway between the directrix and the focus. So the vertex is going to share the same x value as the focus. It's just going to be 3 units above. So that's going to be at 3, 5. Now all we have to do is we have to build our equation. Okay? So since it opens down, we're going to use the equation x minus h equals 4p times y minus k. And then we just plug and chug. So we have x minus 3, the quantity squared, equals 4 times negative 3, which is negative 12, times y minus 5 would be our final answer. Every year I find that certain students absolutely love questions like this because they're good at drawing the picture and they're good at working backwards. These have the potential to be really, really easy for you if you know your stuff, if you know your diagram that we labeled first and how everything is related. Okay? All right, one more question, and then we're done. I love this question, okay? Pause it now and write this down, or at least read it on your own, and we'll jump right in. Okay, the parabolic antenna used by a television station to transmit is 146 inches in diameter. If its focus is 48 inches from the vertex, how deep is the antenna's dish? So imagine right now one of those giant news or security satellites, those big giant white ones that are like a big dish, a big like parabolic dish. Okay, that's actually, I probably should have pulled up a picture for you here, but those are actually parabolic antennas. Okay, I'm not a good artist, but I'll try to draw you one here. Okay, so don't draw this. This isn't going to be what we use, but what those dishes are, okay, is they're giant parabolas. Okay, and a lot of times they've got that thing that comes out. Maybe looks something like this. That's actually not a bad satellite, my people. I'm getting better, okay? So what actually happens here is these satellites are strategically placed, okay? And I won't bore you with a ton of this. Some of you are like, Cosette, I've been bored since you started. So sorry. But real quick, what happens is this antenna right here, this part, is actually strategically located at the focus of this parabola. Imagine taking a parabola and rotating it around 360 degrees, and you get this shape, okay? It's called a paraboloid, okay? It's called a paraboloid. So now what we need to have happen here is we need to figure out what happens when this communicates with outer space, okay? So when it communicates with outer space, what happens is these signals come back in and hit the surface of the satellite dish. Okay, and they bounce off and they hit exactly at the focus point. So everything that hits the surface of that satellite dish actually reflects back to that focus point. Okay, likewise, if you, let me get rid of those. So let's say you wanted to communicate with space. Okay, you emit that signal from your focus point and it bounces off the surface of your satellite dish, and you get a much larger signal that you send up to space. Okay? So now that some of you are completely bored and lost, you can Google this actually. There's a lot of really cool things that you can Google. Google parabolic reflectors, okay? And you'll see some really cool images of this stuff happening. It's called parabolic reflectors, okay? Google it, see what comes up. Okay. All right. So in this particular problem, we're trying to find an equation. We're trying to find the depth. That's what we're trying to find. The depth of the antenna's dish. Okay. The depth of the antenna's dish. So first thing we're going to do is we're going to draw a satellite. Now, this is where some people are always like, how do you know to draw it like this? Well, it doesn't tell me in the problem that it has to open up, right, left, or down. And I think we all agree that parabolas that open up are probably the easiest to deal with. The other assumption that I get to make is I'm going to get to pick where the vertex is located. Again, notice in the problem, there is no rule on where the vertex is located. So very clearly, the easiest vertex to use would be 0, 0. Okay? Now, here is what we know from the problem. We know that the diameter is 146 inches. We know the diameter is 146 inches. That means from this distance to this distance is 146. Okay? Now, let's think about this. If we know that that entire diameter is 146 inches, let's talk about the coordinate of this point right here. Okay? The coordinate of that point is going to be 73 inches to the right of the vertex, but we still don't know what the y value is yet. Okay, we still don't know what the y value is yet. In fact, if I can find that y value will actually tell me what the depth of this satellite dish is. That's what I'm trying to find. Well, some of you might be saying, well, Koza, don't we know that it's 48 inches? No, read it again carefully. It says the focus is 48 inches from the vertex. That does not mean that the depth of that satellite dish is 48 inches. Who knows where that could be located? 48 inches could be up here. 48 inches could be on the interior. We don't know that, so we need to figure a few things out here. Okay, so the fact that the focus is located 48 inches from the vertex tells me that P is 48. Okay, P is 48. So let's build our equation. So we're going to have x minus 0 squared equals 48 times 4 times y minus 0. Okay? Now, I know a lot of things, but I do not know what 48 times 4 is off the top of my head, so I'd have to punch that in my calculator. And I'd get x squared equals 192y. Okay? Now, again, if I'm trying to find the depth of this satellite dish, in other words, that's the depth, the y value when x is 73, okay? And again, if you're still struggling with 73, that's just half of 146, okay? So to figure this out, I'm going to take that x value, and I'm going to plug it in my equation. So 73 squared equals 192y. Again, I know a lot about math, but I don't know 73 squared, so I'd punch that in my calculator. I get 5,329, and then I'm going to divide that by 192, and I get 27.755 inches. So the depth of that satellite dish is 27.755 inches. So, in fact, the focus point is actually on the exterior of that satellite. Man, that's a lot of stuff. I hope you enjoyed it. I hope you found it worthwhile. Thanks for sticking with me all the way to the end. Let me know, please, if you have any more questions or this was terrible or awesome. I'd love to hear it either way. You guys are awesome.